This video is for 5.1 notes. So an ion is a charged particle. So we saw things like sodium ion, fluoride ion. So this one has the positive charge, means it has too few electrons than neutral, and the negative charge means it has more electrons. So an anion specifically is something like fluoride. So there's more electrons than protons. And we learned that this was called fluoride. We take the name of the neutral atom plus the IDE suffix. It's fluoride. I'll rewrite that. And then a cation is just the opposite. I'm going to make it a little bit more. So cation would be a sodium ion, and there are less electrons, or fewer. So this is just the name of the cation. So then this is just called sodium ion. So we've done this before, naming. So if we had calcium fluoride, which just means you have a calcium ion and a fluoride ion, and then we can figure out what that would be. We know that it's CaF2 because of that double switch rule, where the 2 goes there and the 1 goes there. So then basically the amount of F minuses we need to balance out 1 plus 2 is 1 to 2. And the thing about this thing is that its total charge is 0. It's neutral charge for the compound, but each ion has charge by itself. So the only additional thing that we'll add for 5.1 are these things called polyatomic ions. So these are molecules. Let's see here. These are molecules that have a charge, and for the most part, the charges are negative. So you can see that these are all anions. There is one example of something that's a positive charge, and that's ammonium. So we're going to use these exactly the same way we would use fluoride. So calcium hydroxide would just be a calcium with 2 hydroxides. Or sodium iodide would be a sodium with 1 iodide. So you don't have to memorize these names. I'm going to give you this chart, but you do have to know how to use them. So the other thing is I did it in the notes, but so polyatomic ions always stay together. So you're not allowed to break them up. It's 1 unit. If you want to have multiple, you're going to use a parenthesis. So if we wanted to have calcium iodide, it's a +2, and iodide is IO2 minus. So how are we going to put those together? Would be CaIO2, 2, which means the 2 goes to 2 iodines and works out to 2 or 4 overall oxygens. Or really the way you should think about it is 2 iodides. So this is sodium ion. And then you can go and figure out, just go find it, has a nitrogen in it. So it's right there, it's nitrate. So putting that together, this is just sodium nitrate. Ion there. So this is the one that you have to use. It's a metal ion, transition metal ion, so we don't know what its charge is. So we have to use the double switch rule to figure out what is what. So it's copper with some charge that we don't know. And then it's SO4. We have to figure out what this charge is up here. So let's go try to find this molecule. So it is right here. So it has a -2 charge. So what charge must copper have so that one of it balances out with one sulfate? It must be 2 as well. So then we would call this thing copper. We use Roman numerals. All right, so now we have 2 polyatomic ions. We have this one here, which is ammonium, and this one here, which is NO3. So let's find this one here, and let's find that one there. This one here, this is called ammonium ion, and we have NO3, which is called nitrate. So then putting that together, it's ammonium nitrate. So with the table, it's not any more complicated than what we've done previously. It's just now there's more things, but you just look on the table and find what you're using. So there's another kind of naming that we'll do. These are binary covalent compounds. So these are made up of a non-metal and another non-metal. So 2 non-metals together, we can get these compounds. And the way that we name them is the less electronegative comes first. So the less electronegative atom comes first, and then it has with a numeric prefix of how many things there are. So if there's 2 of them, it would be di. If there's 3, it's tri, tetra, penta. This table I won't give you, so these you have to memorize. But it's pretty simple. Mono means 1, 2 means di, 3 means tri, tetra, penta. So these are all prefixes you should be familiar with. The only one that you may not have seen before is mono. And there's only one exception to all this, that if for the first compound, if it starts with 1, if there's only one of them, we do not use mono. So if we have 1 sulfur, we just call it sulfur. We do not call it monosulfur. But if there were 2 sulfurs, it would be disulfur. And then the second element, because this is going to be binary, so there's going to always be 2 nonmetals. The second nonmetal gets a prefix again. Even if it's 1, we put the mono. And then we have the name of the element with the IDE suffix. So name the more electronegative with a numeric prefix and an IDE ending. So this one would be dicarbon. And then what's the prefix for 6? 6 is hexa. And so we name this as bromide. Dicarbon hexabromide. So we have a nitrogen. We're not going to say mononitrogen because we don't put mono for the first one. But we do use mono for the second. And this is just for oxygen. We don't call it monooxide. we put the word together, and we do as monoxide. That's like a finer point. So it's not monooxide. But monoxide. Okay. Se, you got the, you do have to be familiar with the periodic table now. Se is selenium. So, and there's two of them, so it would be diselenium. And then it would be dibromide. There's one phosphorus. So this would be phosphorus, not monophosphorus, but just phosphorus. And then dibromide. Silicon, dibromide. We have phosphorus, which would be a P. And this is pentachloride. That means we have 5 chlorines. We have a silicon, that's Si. And this says we have 2 fluorines. We have dicarbon, which means it's C2. And tetrabromide, it's Br4. So it's pretty simple, pretty straightforward. The main thing to remember, this is for non-metal and non-metal. Non-metal and non-metal, that's when we use mono, di, tri, tetra. Up here, this is the one where we have metal and non-metal, or polyatomic ion. There is no di, tri, tetra. This is not called calcium difluoride because it's a metal and a non-metal. And if you look at these are, for the most part, these are all going to be non-metals. But even when you have metals, when you have manganese with oxygen, this is a polyatomic ion. We can classify that as a non-metal. Well, we can treat it as a non-metal in the naming. The same thing with the chromates. Even though they have chromium in them, they're non-metals. So you can have something like, right over here in the margin, you can even have something like manganese permanganate. So this would be called manganese 2 permanganate. But no di, no tris, no tetras. So that's the main thing that you have to remember, and something that it's easy to get confused.